Hi, I'm Jason Taylor for SSW TV, and we're here today at NDC Sydney. I'm here with Steve Sanderson, a developer for the Microsoft ASP.NET team, and Steve is also an awesome speaker, trainer, and presenter. Steve, welcome.
Thank you.
So this week at NDC, you're doing two presentations, and one of them is on building single-page applications with ASP.NET Core.
That's correct.
Excellent. And can you tell me what makes ASP.NET Core so great that people should choose it for their server side?
For the server side, okay. Well, ASP.NET Core is pretty well established as a very good server-side platform. So, as most people will know, it's got a very rich feature set already. People always tell us how much they like working with the tooling. It's difficult to find something else that's quite as well developed and comprehensive as that. And then in terms of performance, it's really up there with the very fastest of frameworks, so well ahead of many of the other commonly used server-side frameworks. So I think it's pretty well established as a strong candidate for server-side programming.
That's excellent. And using JavaScript Services, we now have access to, how many templates? Is it 7?
Yeah, so the JavaScript Services project it provides a few features. It provides a general ability for .NET code to work with JavaScript code by means of a connection to Node. But also it does come with a bunch of project templates, as you just said. I think it's actually 6 templates that we've got in at the moment. So if I can remember correctly, we've got Aurelia, going alphabetically here, Knockout, we've got Aurelia, Angular, Knockout, React with Redux, and then Vue.js. So that is 6.
Yeah. Okay, fantastic. And so no matter which client-side framework someone has chosen, they can use this approach.
Yeah, that's right. As long as the approach they've chosen is one of those 6, then yes, they can do that.
And we've talked to a few people across Australia, and each time we've asked the question, did we miss anyone's client-side framework? Is it being included? No one has put up their hand. You've hit 6, and it's perfect.
Finally got there. Great.
Excellent. And tell me, we talked a little bit about this before, but what are the 2 common gotchas that people experience when using these templates?
Yeah, all right, okay. So there's one thing that people very often get confused about, which is why when they see this demonstrated, there's this really cool feature where when you edit your code, the changes just show up in the browser automatically. This is built on Webpack's hot module replacement feature, and that's really nice. You definitely want that to be working. But sometimes people say to us, it's not working. I make my changes and the changes are just not showing up. What's going on there? And it basically always comes down to the fact that they're running in production build rather than a development build. Now, the hot module replacement is not turned on in production because it would be damaging for performance, and there's no point because obviously your code is not changing in production. Exactly. So yeah, they need to remember to be in development mode. The other thing is, one of the major features that these project templates supply is the ability to do server-side pre-rendering, and that is where your Angular or React application doesn't just run on the client but also runs on the server, so that we can render the initial HTML and send that down to the browser very quickly without waiting for the browser to download and execute the JavaScript. So that's all very well, but when your code is running on the server, it's running in a different runtime environment to what it runs in on the browser, and so not all of the browser APIs exist. For example, the window object, which is the root of many APIs in the browser, simply does not exist on the server. There's no window there. So if your code tries to reference that, it's just going to blow up during server-side pre-rendering. So what people need to know in that case is you need to somehow account for the fact that your code is running in 2 different environments. You need to be testing whether or not a given API is present. For example, the local storage API can't possibly exist on the server because where would we be storing the data anyway? That wouldn't make sense. So you need to make sure that you're not relying on browser-side APIs that can't exist on the server, or that each bit of UI that makes use of these APIs handles the possibility that it might not be present in a given runtime environment.
Okay, fantastic. And one thing that's caught me up in the past, especially when pulling the source code down from a repo, is that you actually have to run that Webpack configuration manually to build those vendor resources.
Yeah, that used to be the case. Not so much anymore. So in the default templates that we just shipped as part of the .NET Core 2.0 SDK, one of the last minute tweaks that we made was during the build, we check whether or not your client-side files have already been built and are present on disk, and if they're not, then we automatically run the Webpack build as part of the .NET build. So hopefully you won't get too far wrong with that anymore.
That's fantastic. So you've completely removed one of the problems that was facing developers. And once you knew about it, it was easy, but now it's going to do it automatically.
Yeah, absolutely.
So that's great. We often fight at my work about what is the correct approach for building single-page applications. Do we have the client side and the server side in the same project, or do we have them in separate projects? Now, with the JavaScript services and the SPA templates, it's in the same project. Is there a reason why you might want to keep them together?
Yeah, well, firstly, I wouldn't say necessarily that your whole application, the server-side part of it, should be one project. You may have many projects. You might have projects for your domain model, for your data access. You might have projects that surface JSON, web APIs, all kinds of different structures that you could choose according to however you want your thing to work. The project template that we're talking about, they produce a single-page application that allows you, if you want to put as much server-side and client-side code into the same project. But it's really up to an individual developer how much they want to do that. Now, as for why it makes sense to have any server-side code running alongside your client-side UI, well, it's kind of inevitable, really, that in order to actually serve this client-side UI, there's got to be some server there, obviously. Now, that server could just be something as simple as a CDN serving static content if you want to. But if you make it as simple as that, then you are giving up on some of the benefits of having an actual programmable web server there. For example, you're not going to be able to do things like server-side pre-rendering, because obviously that has to run on the server. But there's also many other things that you might want to impose controls over. You might want certain types of access controls that redirect to different locations depending on whether a user is coming in with certain types of authentication. You might want to be implementing things like server-side caching. So you might want to cache the results of doing your server-side pre-rendering. So there's all kinds of stuff you might want to do. And to do stuff in general, you want a general server-side programmable web platform, and that is what ASP.NET Core is. So it does make sense and has a lot of advantages to be serving your client UI out of an ASP.NET server. Now, as for whether or not your web APIs and your domain models and stuff should all be in the same project, that's just completely up to the developer. You can split that whatever way you want.
Yeah, and I think today most people are splitting those out, but really it was the question of how much do you put into that front-end web API, and then perhaps how much do you put into those back-end web APIs? Yeah,
and the requirements are going to vary from one project to another. A sufficiently simple thing, you might want to just stick it all in one project, but by the time you scale beyond one or two developers, you're probably going to find it beneficial to have a bit more separation than that.
And if at some point you created an application using the SPA template and then you wanted to move them apart, is that easy to do? They're quite separate, aren't they, already?
Yeah, I would think so, yeah. If you've implemented a bunch of web APIs inside your project, then what have you got there? You've got a load of controller files, you've got probably a load of domain model classes, you've got some other business logic and such. Really, just copying those files into a new ASP.NET project to act as a web API server is not going to be a big job. I would hope in half a day or something you're going to be able to have restructured your project like that. It shouldn't be a big deal.
Exactly. Okay, fantastic. And what about Knockout? You're the author of Knockout. My manager likes to say that Knockout was knocked out by Angular.
Okay.
What is the future of Knockout? Where is it going?
Well, firstly, I personally have very limited involvement in Knockout these days. So there are 4 people on the core team for Knockout. The others are still pretty active. So there's plenty of activity and community support and such going on, but I personally have relatively limited insight. I've essentially just taken my hands off and said, you know, you guys can go and develop this in whatever way you feel is best. As for future stuff, the main piece of work is going on inside an entirely new project called Total Knockout, or TKO for short, which is a complete from scratch re-implementation of all of the Knockout concepts, but redone in a much more modern way, and also extended to support many other scenarios that I can't even tell you because I'm not personally involved in it. So that's work has been going on for quite a long time, like about a year or something.
Okay.
And I know that it's at least at beta stage by now, but I don't know exactly how complete it is. And when that ultimately gets released as a final thing, I think the idea is that that is going to adopt the name Knockout 4. So that will be regarded as being the natural path.
Yes.
However, it's still possible that the community might feel it'd be better to give it a new name and actually go forward with the Total Knockout branding. But that's still a final decision to be made on that.
Okay, fantastic. So maybe some interesting things coming from Total Knockout in the future.
Much.
Well, that's great. And in the talk that you gave this morning, you introduced WebAssembly, and that was pretty exciting because you showed us how we can actually run C# on the browser using your experimental project Blazor.
Yeah.
Can you tell us a little bit more about that?
Yeah, absolutely. Okay, so WebAssembly in general is a way of delivering code to a browser, which is a more low-level binary code format. It can't do anything that regular JavaScript can't do, so there's no security implications. Everybody always thinks, oh, it's got the word assembly in it, therefore it's running native assembly code and it's going to start, reading files from my disk and accessing my USB devices and stuff. But it cannot do that because it is just limited to the JavaScript runtime environment. In a way, you can think that it is JavaScript or a certain subset of it. So that's what WebAssembly actually is. Normally, when people want to create a WebAssembly file that can run, they will compile to it from another language. And historically, the easiest things you can compile from are C or C++, because we've had the Mscriptum toolchain, which takes those and compiles to WebAssembly, which is all great. So what I've been doing with Blazor is I took a .NET runtime, which itself is implemented in C, and then I use the Mscriptum compiler to compile that .NET runtime to WebAssembly.
Wow.
And once that is done, it is then possible to load regular .NET assemblies inside the browser and have them running all on this WebAssembly runtime.
So that was amazing. And what was that .NET implementation that you took? That was...
Yeah, okay, so I found a third-party implementation of a .NET runtime called .NET Anywhere, or DNA for short. That's been around for a long time. I think it's about 6 years old, and it's not really been developed significantly since it was originally created, and it's not very widely used either. So my usage of that has been as a experimental proof of concept prototype kind of level. Now, theoretically, it could be developed into a really robust, modern, fully featured .NET runtime, but it wouldn't necessarily have to be. It might be possible to take another .NET runtime, such as the .NET Core runtime or something, and correspondingly get that running under WebAssembly as well. Theoretically, that's never been achieved yet, as far as I'm aware. I do know that the Mono team have been doing some work on getting Mono to be built to WebAssembly, and they've had some success with that as well.
Fantastic. So during the demonstration, you actually showed us how you could create a C# application running on the client side through WebAssembly that actually used Razor pages.
Yeah, that's right. Yeah.
So that was amazing. Can you tell us a little bit more about that and kind of what the limitations currently are to the feature set to what you can do?
Yeah, okay. All right, so being able to run .NET code inside a browser is very nice, but you can't do very much with that on its own besides just print stuff to the console. If you want to build a realistic application, you need to have a way of rendering UI properly in the browser, and then you want to get into all the sort of niceties of modern programming, such as having a hierarchical component model and being able to do things like automatically update the code when you change your sources on disk and all that sort of stuff. So just to continue this experiment, I built a very small UI framework that that was for .NET code running inside a browser to render an HTML-based user interface. And the way this works is that you write your pages with Razor. Razor is the view engine that was originally created for MVC, but in general can be used as a way of mixing HTML and C# together to produce HTML with C#. So you've got a bunch of Razor pages that contain both C# for logic and HTML for presentation. And within my little framework, which I call Blazor, those are the components. And then the framework can stitch all these components together to render them as a user interface. And then you can take events like clicks and all that kind of stuff. And each time you do that, we'll re-execute the Razor page. And that produces a virtual DOM structure, which we can then diff very quickly against the previous version and update the DOM in the browser's memory.
Amazing. And we looked at the size because you'd think immediately, well, this is going to be a really large page because it's bringing down the .NET framework. How big was it?
It's much smaller than many people expect. You might think it's going to be tens or hundreds of megabytes to embed an entire .NET runtime inside your page. But actually, WebAssembly is an amazingly compact format. And also, you need very little part of the .NET standard libraries in order to do something like a client-side web application. So it turned out that it was something like about 330 kilobytes for the whole thing there. Now that does come with a lot of limitations because, like I said, it doesn't include every single .NET API that you would ever expect. And largely this is because most of them don't make sense anyway. Like it doesn't make any sense to access Windows registry or, you know, things like having a SQL client. You really should not be connecting to your SQL database directly from a client-side web application.
Of course.
So tons and tons of the .NET standard libraries are not relevant. And by the time you take all that out, you do end up with a very minimal and lean application.
Okay, fantastic. And so what does this mean? Where do you think we can take this in the future? Can we do away with all of these JavaScript frameworks and just do C# in the front end and C# in the back end?
Well, maybe, theoretically. I think that realistically, what we're going to see over the next 5 to 10 years or something in web programming is a move away from the monoculture that we've got at the moment. Today you have literally no choice but to write JavaScript. I mean, you can do TypeScript or CoffeeScript or whatever, but basically these are very small, thin layers over JavaScript.
Yeah.
You can't, for example, say, well, you know, I really want to do a completely different type of programming language. I want to use something like Rust or F# or something else like that. Well, there are ways. People have found ways of doing it, but it's very niche today. Yep. Whereas WebAssembly makes it possible to do that in a much more sort of production grade way that's really going to work completely in all the ways that a person wants. And so what I hope we see over the next 5 or 10 years is more diversity in the way that web applications are built. So just like people who are building native applications pick the best language and the best runtime for the type of thing they're building, hopefully in the near future people will have that same level of freedom when they want to build a web application. Should it be written with a functional programming language or something low level like C? It just depends what you're trying to build and what the skill set of your team is. And so that's what I expect to see. And .NET is one of those things. .NET is one type of runtime that you can use. C# is one language, F# is another, and people will choose what is best for their application.
Fantastic, and that might help to reduce the learning curve that's required to get into web development, because right now there's so many frameworks, so many technologies and so many tools. I imagine that must be a pretty steep curve for new people.
It is a steep curve, yeah, and it's sort of counterintuitive to say we could fix that by adding even more languages and runtimes and so on. But I think the point being that you pick the one that makes sense to you as a business based on your team's experience, and you have that freedom to do that as opposed to being required to use the one and only technology stack that is possible and yet is unbelievably fragmented at the same time.
Exactly. Fantastic. Well, are there any questions from the audience? All covered? No problem. Well, Steve, thanks so much for coming to this session today. Really appreciate speaking with you.
Great.
I'm Jason Taylor for SSW TV. Thank you.